that binding it to the workload identity. So we don't need to create a more secret on Kubernetes. We don't need to add the Google Service account into Kubernetes, which this is not secure anymore. Next, for GKE autopilot, we need minimum two subnet of the network. The first one is POD subnet, and second one is service subnet. POD, of course, for networking between the POD and the services. And the service subnet for service and cluster IP. Okay, this is the example of the GitLab CI/CD. There is a stage, then we can define which branch will be deployed. Right here, we can see only main. That means we only deploy the main branch, so it will be consistent. Next, we can see the main part of the CI/CD script. We can, like here, there is build for building the image of the container. I'm using Docker to build the image, then push it into the registry. In the next stage, I deploy it using Kubernetes kubectl set image. So the newest image will be updated into the deployment using kubectl set image. Actually, for the CI/CD script, this is only the simple example, but it can be more complex if we add more integration. It's look so very simple, right? So it's enough for us to deploy the application into the GKE autopilot. Okay, challenge and best practice. In GKE autopilot, we don't need to add manually the resource, but the resource is limited. We are not able to manage or custom the nodes. So the node not persistent. Let's say currently the active node is 2. In the next few hours, it will be 1 based on the workload of the application. So we are not able to custom on the nodes. Then network complexity. Before we deploy the GKE autopilot, we need to prepare the subnet of the network properly. Minimum we have 2 subnet, and don't mix it with other resource. The third one is GitLab Runner not supported in GKE autopilot. Why? Because GKE autopilot nodes, it's not supported for custom security configuration. So because the GitLab Runner is need authorization to access the Docker. Docker need access to build and deploy the application, but it's not able to do in GKE autopilot nodes. And the last one, workload identity misconfiguration. Like I said, workload identity is for authentication into the Google Cloud Platform feature. For smooth deployment, use workload identity for secure authentication. This is the main feature of the GKE. No need secret to pulling the image from the artifact registry. Maybe after my session, that will be Kubernetes Kung Fu explain what secret is. Next one is monitor and log. We can use Google Cloud Logging or Prometheus to monitoring our application. But also we can integrate with other monitoring external. Then for better trial and error, we use blue and green deployment. So just do the test in the blue deployment. Please don't do the test on the production deployment. It will make you work in the weekend. Okay, the last one, keep CI/CD pipeline fast and efficient. Because if we misconfiguration on CI/CD, it will harder to find the error. Because if we integrate the CI/CD tools with one or more tools, we need to find out what the error, what the bugs. So always check the CI/CD script. Okay, that's all for my talk. I think the time is up already. Any question?
Just before we do, thank you for your time. We've got about 4 minutes. However, Alan,
Okay.
So, do we have a question?
Yeah.
Is the autopilot able to scale the containers to zero, like in a similar to a serverless, where if you don't have any traffic, you don't have to pay anything?
Yep, correct. We can set the limitation of the POD until there is no POD active. Okay, correct. That's why autopilot is optimization of the cost for our billing. And the the crucial part is you need to limit the maximum of part unless you have much billing on your wallet.
I quite like that with the local entities. Use Amazon is very this to avoid having to move keys around, to use the workload entity instead of having to pass the keys around. So, quite a good idea. And worth doing. We've got minutes. Any other questions, comments? Yeah.
So if I remember correctly, autopilot is a little bit more expensive, right, compared to GKB. At which point would you say autopilot is no longer cost effective for the
Because autopilot we only pay the active resource, right? Different with the standard one. Standard one, if we create 5 nodes or 10 nodes of the cluster, either we use it or not, we will pay all of them. Yep.
Yeah, I guess that makes sense. Like, do you roughly know what's the cost of autopilot versus GKB?
Yep. Maybe for for more scale, it will be more expensive in GK autopilot, but I think for large scale, it will be more efficient for using GK autopilot. Yeah, I already compared the standard one and the autopilot. If we're using for only 1 or 2 application, it's too expensive. That's it. Okay, I think enough for my session.
I'm sure that we'll actually get to. Well, you get a lot of time. We've got a couple of minutes for the next session, but thank you very much.
Okay, thank you. I'm sorry for any mistake. See you in the next event.
That's yes. All right. Next up we have Alan.
That's my full name is Ishilasan.
One is fine. Right.
Thanks for your recording and
So
thanks
Alan
for
will
speaking.
be
Yeah,
product
it's working.
engineer for Scotland. And we're going to be learning about Kubernetes Kung Fu.
Yeah,
Here, which martial arts.
I learn. I'm studying MMA actually.
Well, there's sort of a neglected part of something there. Right, go ahead.
So can I start?
Yes, go ahead.
Yeah. Okay. So good afternoon, everyone. I'm really excited to be a part of FOSSASIA Summit 2025. I'm Alan Vai, a backend engineer working at Strawberry USC. So I'm currently working on microservices and scalable system. I'm also an open source contributor and love sharing insights on evolving tech ecosystems. So today I'll be diving into Kubernetes Kung Fu, mastering microservices and containers. So where I'll be breaking down the complexities of Kubernetes and make it beginner friendly. So I'll be covering the base concepts today. And yeah, so moving on to the next. So today I'm planning to give an introduction to Kubernetes, covering the architecture, then some of the core resources that are used in Kubernetes, and also I'll be covering Helm, and I'll be also giving a quick intro to microservices orchestration. Yeah. So what is Kubernetes? Kubernetes is an it's a container orchestration tool that helps in deploying and scaling of containerized applications. I know this doesn't make any sense right now. Let's begin with an example. Let's say I have an application which is running in a VM, maybe like an AWS or GCP virtual machine. and it has let's say it has 3 containers running right now. Say one is a front end app, the second container is a server, and third maybe like we have a database right now. So let's say one of our containers go down, let's say our servers go down. So we want, there's a downtime in an application. So let's say in that case there's significant amount of less downtime. Let's say our application crashes at somewhere between 3 a.m. at the night, so there is no one to go and manually restart the container so that the application can work properly. So let's say I've mentioned only 3 containers in my application. In real world scenarios, we might have 1,000 containers running there, here and there. So we needed something that can automate, that can go and automatically check the health of every container that is present. So here for our rescue, we have Kubernetes. So what Kubernetes does is, it let's say I have n number of containers running. It goes and check health checks on every containers, and let's say if one of our containers die, it can automatically restart the containers. This is one of the typical use case of Kubernetes. And let's say for a particular container, the traffic that I'm receiving is very high. So based on the traffic received, I need to automatically scale my container size. Say I want to increase the number of instances from 1 to 2. So Kubernetes does too. These are some of the very limited use cases of Kubernetes. It can do much better. It can do a lot of things. So now moving on to the architecture. Before covering the architecture, everyone must be familiar with Kubernetes cluster. So what is a Kubernetes cluster? Kubernetes cluster basically consists of all the resources that are required to run a Kubernetes application. So it basically consists of a control plane, or we can call it as a central computer, and a group of worker nodes. Worker nodes, as in the computers which run the containers. So now let's take an example of worker nodes. Node 1 and node 2 are worker nodes. Let's check into the components of our nodes. So the nodes are the place where our container works or container runs. Let's say I have a container 1 running at node 1. Containers does not have a standalone runtime in worker nodes. They are encapsulated in pods. I'll be covering about pods in the next slide, so I'll skip that one right now. And we have a kubelet. So what is kubelet? The kubelet is the one in worker node that manages all the pods, and communication between master node and worker node happens through kubelet. Then we have kube proxy. Kube proxy is the one that enables networking between the pods and between two pods in a worker node and between two worker nodes. Then we have master nodes. So this is master node is one of the most important component of our Kubernetes cluster. So we are interacting directly with the master node either through a GUI, or we have a CLI for that. It's called kubectl. So the components of master node are kube API server. So kube API server is the one. See, when we type in something like kubectl create to create a resource, we'll type in kubectl create port. So the control goes to the API server. So it's the API server that transmits that commands or give commands to the worker nodes. Then we have the controller. Before that, we have to discuss about scheduler. Then we have schedulers. So scheduler is the one that, let's say I want to create a pod, single pod or double pod. It's the one that finds out a suitable worker node. Say I want to create a pod with certain RAM and memory limits. So it identifies which worker nodes have the required specifications and allocates that port to a specific worker. Let's say I want to evict a certain pod. It's the scheduler that does the eviction also. Then we have the controller manager. So controller manager always maintains the state of our worker node. Let's say I always needed like 2 ports running in node 1. Let's say one of our port gets killed. So scheduler looks into the node 1 and checks the number of ports. When it sees that there's only 1 port left, so it gives a message to the scheduler to add a port to node 1. So the state of the worker node is always maintained. Okay, so now moving on to the pod. So pod is the smallest unit or smallest resources available inside our Kubernetes cluster. So as mentioned earlier, containers don't run alone in a Kubernetes cluster. They are always encapsulated within a pods. So there's always a one-to-one ratio between the number of containers and pods, but it's not always one-to-one. There can be multiple containers in a single pod. So let's discuss about the ways of creating Kubernetes resource of pod. So there are two approaches we have. So one is the imperative way. In imperative way, we'll tell our resources should look like. We'll tell the final and the initial state of the resource. Let's say I already mentioned we have a command line application to create Kubernetes resources. It's kubectl. So with the imperative approach, I'll say I just need to create kubectl create pod and the pod specification. So it doesn't need to know about the state. The second way is most common way. It's a declarative form of approach where we'll be specifying how a pod is going or pod or any resources is going to look like. So we'll just in a file in a YAML file we'll declare all the specification and when we run the command to build the resources, it would take care of the state which is gonna be achieved by that resources. Now looking onto the commands there, so first we should specify the kind. So the kind, the type of resource we are gonna create. So for this pod, we have to specify pod, and API version is something like a directory or a folder which contains all the resources which we are gonna create. So pod service is another resource. Pod service, no deployments. Secrets are all present under a folder. We can call it. It's analogous to a folder. The API version v1, and metadata is the part where we mention the name. Maybe we can give a name to a pod. I'm giving it as a Nginx, and then there are labels. So labels is basically it acts like a selector. So when I'm gonna create a second resource, let's say service, which I'm gonna discuss in the further slides. So if another resource want to access or use this particular resource, it is gonna call by its label, not its name. Yeah. So then there's a spec section. Under spec, we'll be mentioning the container specification. What is the name of image and what is the image? So image is basically where what is the container we are gonna use, and the ports and the port at which this Nginx or image is running. Next we have services. So services is basically a resource. Let's say I've created a pod. That pod is particularly accessible within the Kubernetes cluster. We need to access it outside. So we needed something, a Kubernetes resource to access it from the outside. So we have services. Services basically, exposes the ports outside of the Kubernetes cluster and enables intercommunication between ports. And there are three types of ports: cluster IP, three types of services: cluster IP, node port, and load balancer. So we'll gonna cover node port. So node port is basically used to, let's say I have a Nginx app running inside a Kubernetes cluster at port 80. I want to access it from outside. So we need to create a service of the type node port to access it from outside or through our browser. So this is the specification to create a node port services. So we have to specify type of kind service, and API version is v1, and metadata is similar. And under specs, we'll mention the type is node port, and we have under port section, we have three different entities: port, target port, and port. So what is port? Port is basically, at what port we are going to expose our service. And target port is basically, the port at which our application inside our container is running. And we could optionally give a name to the port. So this is the basic specification to create a node port. Then we have cluster IP. So cluster IP is basically the one that enables intercommunication. Let's say we have three containers in our application: front-end, client, and database server container. So if I want to enable communication between the server and the database containers, I needed some service out there. So this is the one that enables that cluster IP. So specification is similar to node port. The only difference is a default type for service under spec is cluster IP. So we don't have to mention the type there. we'll select the port. Let's say I want to connect to the database port. So I'll mention, see the selector and the label of the port. The label I gave here is app Mongo. And under ports, we'll mention the service port at which the service is exposed, and the port at which target port is the port at which the container is running. And next we have deployments. So deployments are basically controllers that helps in creation, scaling, and updation of ports. Let's say I have in my application I require two server ports to be run at every time. Say if I didn't have something like a deployment resource out there, and if one of the port dies, I have to manually go up there and restart the port. With deployment, I could mention that each time I must always have two replicas of that port running. Say, and let's say if one of a port gets killed or crashed, deployment automatically creates another port and maintains the state. So it is like a state manager, which ensures that required number of ports is always available. So this is the YAML for creating deployments. It's similar. Under specification, we can mention the number of ports which we want to maintain. That's replicas. And selector is the place where we match our selector port. Port label is app client. Under template section, we'll specify the requirements of the port. It's similar to the one which we have shown earlier in the port section. And next is Helm. So if everyone is familiar with Python, we have pip to manage package dependencies in Python. Similar to that in Kubernetes, we have Helm to Helm chart to simplify application deployment. And Helm is the application manager or package manager for Helm charts. So what does Helm chart do? Yeah. Let's say while creating resources in a declarative way in Kubernetes, we have to first write all our YAML files, and after that we have to give in a command like kubectl apply -f a file name. So every time I make a change, I have to do this, write this command kubectl apply -f. In order to avoid that, we have something called Helm chart. Under Helm chart, when we can create a custom Helm chart. So when I say Helm create something, maybe a name, Helm create web app, we'll get a folder. So under folder, we have the template folder where we'll write all. There will be a template which is automatically generated for us. So under these, we'll specify our requirements, and we have the chart.yaml. And when we write Helm install the path to the folder, all our resources will be automatically created. So we don't have to apply kubectl command every time. And for microservice orchestration, always use deployment for automated scaling and updation. And init containers must be there always. Before starting up our containers, we should always ensure that all database migrations to be completed. That init containers take care of that, and the sidecar patterns is deployed along with main containers for logging and monitoring purposes. Yeah, I'm gonna end my presentation with a chat code from AI ChatGPT. So Kubernetes is a martial art of microservice masters, and you can orchestrate anything with precision, scalable, and resilience. And these are the references which I take. Yeah, thank you so much.
Thank you. Before we move to a just room, go ahead and set up. This is Helen's DIY setup. Right. Questions on Kubernetes and Kubernetes. My topic is so exhaustive, nothing left for us. No question?
Yeah, thank you.
Oh,
Thank you. Amazing watch.
oh yes.
We have to import the HTTP, but some of the stuff is like comments.
Yep, thank you. So that's for audience and that's for recording. Okay.
This is for
Yeah. Does it work? Okay. Ah, that's for. So we are starting at 10 past 10. Yeah. Oops. Oh, that's okay. Yeah. Just in case anyone's wondering, in the last couple of years, we've had much larger online audiences than in person. So that to allow for the possibility for video in rooms, but also for the expectations of the remote viewers, asking to get a whole lot of stuff and until this schedule minute and a half. All right, so thank you for that. So now I have Justin Media. This is developer at Microsoft. Is that integration testing with testing campus? Sure. Go ahead. Hello, everyone. Yeah, thanks for joining my session. This the session is purely the workshop, hands-on workshop. So you are I'm supposed to you are ready for like a hands-on, your hands dirty. Yeah, so today I'm going to talk about next 15 minutes. We are going to use test containers to test your application within container. So I'm Justin from Microsoft as a principal cloud advocate, and these are my social media profile. So if you follow me on there, you will be able to see like lots of talk about containers, cloud native, and AI, whatever, and sometimes test joke. So let's start with this conversation. So we are talking about cloud native. We are talking about cloud native. So what's the definition of cloud native? There are so many definitions defining the cloud native, but the one thing I'm going to emphasize is that scalability, right? So if we are talking about cloud native, then we need to consider like from 0 instance to the multiple instances at scale, right? So it doesn't have to be containers, right? So let's say serverless. So this is also considered as a cloud native. But if we use containers, then it makes our lives much easier because we are everything put into the containers, right? In that case, so if we want to use containers, so we need to build a container image first. And if we build container image, then we need to use Dockerfile.
Or the YouTube streaming is not showing this slide right now.
So what do you mean?
So I need to enter this link. For the streaming.
Oh,
Oops. So
Yeah, post link, perfect. Sorry, I'm really sorry. This link.
The magic technology has to create magic.
yeah, post link
Post link dot parcel. BRCL
also
dot
dot
app.
Thanks for waiting. I am.
3-hour afternoon.
So I haven't logged into the StreamYard
For
yet.
the YouTube
Yeah.
stream. Sorry.
It's $20. Yeah. Okay.
Okay, and also
At present, we do streaming using its
can you mute the this side tab?
rather than even else magic box yet. Magic box
And pause this one and this one also.
Okay.
Yeah, and you can share in the screen, present the screen to the entire screen, show screen. Yeah, and use the screen to. Okay.
Second screen there.
Yeah. Okay.
So where is my slide?
No. Right. Okay.
My slide has gone. There you go. It's working? Yeah. Right. So I lost a few 2 or 3 minutes. Yeah. So let's make a quick. So yeah, back to the topic. So if we want to use containers, we need to build a container image. And if we want to build container image, then we need to use Dockerfile. Or sometimes we don't need to use Dockerfile. So I will touch that later. And mostly in nowadays, we are using like we are in a the microservice architecture environment. In that case, we need to use we need to use like the multiple containers at once in one application side. So if I want to use multiple containers at once, then Docker Compose is something like for container orchestration. So in that case, so if my application is up and running in a container environment, so if we are building application locally, unit testing locally is fine. But if we put our application inside containers, it's really tricky to test our application. So like how to ensure my application, whether my application is the running properly or behaving properly within the container, right? In that case, it means the how to test end-to-end, how to make end-to-end testing our application using container orchestration. That's something we are facing challenges, right? So in that case, we are using test containers. Probably you heard of that. So this is the website of testcontainers.org, and it has multiple the SDKs the offered, like from Java, Go, .NET, Node.js, Python, everything. So if we prefer to use any of SDK, and if you are writing an applications in sort of this language, then use this container. The test containers is really good for your end-to-end testing. So, so you are running the containers on your local machine, and with these test containers, actually activate or running your containers within the code and do the end-to-end testing with your code. And also, that's something we can do. And another one is .NET Aspire. So if we want to use test containers, we need to build container image first. But if we use .NET Aspire, we don't actually even need to build container images because .NET Aspire takes care of the building containers as well. So yeah, this is the .NET Aspire the website, and so this is the open source for the Microsoft. And yeah, so what .NET Aspire does is that it builds container image for us, and it orchestrates all the containers within the single application side. So that's the container orchestration framework. So even if it is written in .NET, as long as you have the applications running in different languages, as long as it is running in containers, and .NET Aspire can take care of that. So we can also test the end-to-end test using .NET Aspire as well. Okay, so yeah, I have spent so many talks here, so I will give you much more time for the hands-on sessions for today. So this is the object of our hands-on workshop. So the first one is that, so we are building application. We are containerizing our applications using Dockerfile, and we are orchestrating our containers using Docker Compose. And we are testing those containerized applications with test container. And if time allows, I think, yeah, we are also covering .NET Aspire to orchestrate all the app containers. Also, we are doing the test containers. We are doing all the end-to-end test using .NET Aspire as well. And for the UI testing, we are going to use Playwright for UI testing as well. And yeah, so time is ticking. So this is the workshop timeline. So we have 6 different steps. So first one is setting up your development environment, and second one is using Docker and Docker Compose, and third one is API testing with test container, and fourth is end-to-end testing using test container and Playwright, and fifth is .NET Aspire orchestration, and finally end-to-end testing with .NET Aspire and Playwright. So this is a workshop repository. So you can take a picture and type this GitHub repository to get the workshop material. And the good thing is that even if when you visit this repository, it will display a Korean. But when you scroll down, there are 2 languages available as well. So in English and Thai. So you can if you are not familiar with Korean, that's fine. You can use the English language one. And if you are not familiar with both languages and you are very familiar with Thai, then there is another Thai language the material as well. So go there. And the good thing is that you might be getting messed up while you are doing the workshop. So, but don't panic. There are so many test and save points as well. So if you get messed up, just delete. Then come back to the save point for each step. So you can start from there again. All right. Yeah, the setting up the developer environment. The first step is setting up developer environment. And I think I will give you like around 10 minutes for the setting up this one. So the first step is setting up developer environment. And clone this workshop repository in your local machine. And this setup includes the .NET 9 SDK installation on your machine, and the Visual Studio Code installed on your machine, as well as the Docker Desktop. So, you know, Docker Desktop is free for personal use and this environment, so it's okay. Right, so this is now 2:20. So I will give you 10 minutes to set up the thing. And if you have any question, please let me know, then I will show you. So this is the test container workshop repository. When you fill that, and there is documentation here, and there is step 0 document here. So there are, oh, that's Korean. Oh, that's fine. So there is translations in English. Yeah. So document. So step 0, and this is the document we are going to use. And if we prefer using Thai, there is a translation in Thai as well, right? So you can use either. So the first step will be Okay, so this is the first step we are going to do. Yeah, so follow these older steps. Probably you are all familiar with all the terminal command and if once you download install an .NET SDK, and you will be able to use that thing. And also in order to use Playwright, probably you need to download PowerShell as well. The Playwright installation requires PowerShell. And also PowerShell is available on any Linux box as well. And also the install Git, you must have Git for now. And probably you need to download GitHub CLI and Docker Desktop. Right? And once you get everything, you can run the Visual Studio Code on your machine. Visual Studio Code also is also available on the Linux box. Yeah. So this is the thing. So once you clone your repository, you will be able to see this test container workshop on your local machine. And once you run this GitHub git remote -v, then you will be able to see these two things, origin and upstream. But if you see dev kimchi on your origin, then something was wrong. So you should, because you haven't forked this repository in your local in your account yet. So make sure so this repository is possible. Yeah, and this is the one for the extension. Yeah, that's it for now. So once you, so I'm hoping you finish up all the development settings there. Did I put dev container here? Oh, otherwise you might be using the GitHub code space here. So there is a code space, and create the code space instance here, which we can use the GitHub code space or dev container for this workshop. So if you don't want to contaminate your machine with .NET SDK, then you simply use a code space. So let me know while you are having a kind of technical difficulty while you're setting up this developer environment on your machine. Then yeah, just raise up your hand and let me know, or use dev container. We covered dev container session today, right? Yeah. So if you finished it already, then simply go into the next step to create Docker file and Docker Compose file. So I have 2 minutes left. So in 2 minutes time, I'm going to cover this one. Right. So I'm assuming you completed all the setup for your local machine. Now I'm going to move on to the next step. We are going to use Docker file and Docker Compose. So we can run our application on our local machine, right? The front-end application and back-end application as well. So in that case, oops. Okay, is it correct one? Yeah. So if we complete building our application on our local machine, then the next step is to build the container image with this front-end application and the back-end application. And also, because we have at least 2 applications up and running at the same time, both one for front-end and the other one for back-end. So in that case, we need to orchestrate these 2 applications at the same time for the users to work with. So we need to have some sort of orchestration feature for those containers. So as I mentioned before, so so what we are writing the Docker file is that we are we are building the .NET application, and within the Docker file we are using multi-stage build the strategy. So using the first image we build the artifact from the .NET application, and the second stage we are only using the .NET runtime, so that the size of the container image can be shrunk down. And also, we use the Docker Compose for container service discovery as well. Right? So without Docker Compose, it's possible for the service discovery, but it's kind of tricky. But the Docker Compose makes a lot of the easier. So this is the first step. Oops. So this is the first step. So the first one, when you copy the save point at the step 0, they will have like 5 different the projects here. So web app is front-end application, and the weather API, product API, both are the back-end API, taking care of the weather data and product data. And these product data and data entities are basically the database handling the layers. So these two things are part of product API. So we have, based on this project, we are building our application. So we are building our application in here. So the first step will be we are running 3 instances on our local machine without using Docker. Then we might be we want to make sure these 3 applications are up and running properly and they are talking to each other properly. After that, we are building applications using Dockerfile. But you know, if we want to use Dockerfile to build a container application, then we need to figure out how the projects are the project dependencies. For example, web application and the data entities project depends on the web application. Oh, no, the other way. So web application has a dependency on the data entities. Also, product API has a dependency on product data, which is talking to the database. And also data entities has the database the data structure. And also weather API also uses data entities. So these are all the dependencies. So with Dockerfile, we need to figure out those dependencies as well. So if we run, so we create the Dockerfile like this, Dockerfile.web app, then these are the Docker files we are going to define. So you know, all I'm expecting you today is that just copy and paste on your Docker file. So the first part, the stage is building our application, right? So using the .NET, the Alpine Linux using .NET SDK, and build this application and create an artifact into the app directory. And the second stage is we are using the .NET runtime and on Alpine Linux. In here, so based on the artifact previously generated in the previous stage, and we are just copying this one into the runtime container and just simply run it. So this is the product Docker file for the web application. And this is the key part for the copying those dependencies, right? As I mentioned, web application has a dependency on data entities. So we need to copy over these two projects as well. The same rules apply to the product API as well. So in here, product API has dependency on these two things. Product API depends on product data, and product data depends on data entities. So these are all dependencies. So we need to copy these 3 projects into the container to build application properly. So we are also using the same the multi-stage approach. And here, so once we build once we complete writing Docker file, then we can simply build the container image using Docker build command and run this one into like this, using the Docker run. So that's what we are going to do. Now, so we have web application, we have product API application, and we have, where is it? Yeah, weather API application as well. So I didn't put the detailed instruction in here. I will leave that to you. Then once we complete all the build all the 3 containers, then probably you won't be able to see the application is up and running because they don't know each other. So after that, we are doing some sort of the container orchestration, right? So yeah, these are the things we are going to do. So we have now is 4:37. I will give you 10 minutes. So we will finish up at around 2:47. Yes. Oh, no. So there is, where is it? Oh, there are so many. So when you go here, so when you find out there is a save point here, yeah, so we are in the stage 1. So this is the source code we are going to use. So read through the instruction material. Then the stage 1 actually copies the source code from the step 1. So there are already products here, right? So don't worry about you don't finish within the given time, because it's all the self-paced one. So once you after this session, you will just follow the old instruction up to the step 5. Then you will be able to you will be an expert of test containers.
We can use Podman.
Why not? As long as it build container images using Dockerfile. But as a Docker captain, what should I say? What should I say? Right, we have 5 minutes left, and in 5 minutes time, we are moving to actual test time. Is there any questions from the online? Do we have any questions online? Or I don't know. We are streaming, right?
On. I'm learning piecemeal how the streaming is working.
Okay.
Feeding multiple networks.
Okay.
Feeding two different
Mm,
technical approaches.
mm.
So this is feeding directly from the to my screen.
Okay.
That the networks in China
Ah.
are being fed differently.
Okay.
You are able to browser
Mm.
feed the Chinese networks.
Okay. So I
Best to understand why we
yeah.
have two systems. So we have two systems. So
Right. So I don't have to worry about the reactions.
everything is fine. If you're not fine, it's a little bit.
Okay.
So, it's more that I didn't know we were doing it.
Mm.
So because the next two speakers are also workshops,
Right.
it's almost certain that we're going laptops.
Okay.
In which case,
Mm.
we've got to go through the same process.
Sure. Yeah.
Doing setup, not
Yeah.
maintenance at all.
Mm. So how do we get all the questions from the online visitors? We don't.
Oh, you can? Okay. I didn't know that was easy. Okay, so please do tell me if that happens. Good compliment.
Right. So we have 2 minutes for the next steps. Right, so now we are moving on to the next step. Now we are using test containers for API testing, right? So our application is already containerized and we are running this container as a backend API. Now, so if we run a unit test on our local machine, that's totally fine. I know, I'm pretty sure you know all that. But if we want to test already running in a container, running on a container, running in a container, then yeah, how can we do that? Test containers. So this is the one we are going to the practice. And in the test, we are using test framework, using NUnit. Probably if you are a .NET person, then you might have of NUnit. Also, that test container, how that test container works is that we create container builder first. Then with this container builder, it declares which container images we are going to use. That can be either like on our container image just on our local machine, or can be somewhere from your container preferred container registry service. And also we use the port binding. So each container has inside their own container port, right? And that need to be exposed to our local machine. I mean the container host. So sometimes it should be like the deterministic, or it just but for the container image container testing, it should be randomized. Otherwise, what if I run the containers, the test containers every single time, it should change every time. But within the container, it's always the static, right? Yeah, and also, yeah, we are going to test the container image auto build process, right? You know, test container doesn't build a container image by itself. We have to build, we have to provide the container image to the test container. So during our practice, we are automating the container image build process within the NS build. So we are doing that. And this is the NUnit the capability. So the building container is just one-time thing, right? So there are so many testings in the test project, but each time we don't have to create or we don't have to build container image. So it's sometimes so we need the only one time runner called one time setup and one time teardown. So one time setup means we run only once before everything, and one time teardown means it runs once only after everything. And setup and teardown is it runs before each method, each test. And teardown means it runs after each method. So these are two differences. So this is doing the API testing, and we are doing the same thing on the end-to-end testing as well. So we are doing the step 2 and step 3 together. So end-to-end testing means the data, so user inputs data from the front end, and that actually request comes from front end to back end, right? In that case, how do we make sure these data is this request is running properly? In that case, we are doing end-to-end test from front end to back end, right? That includes UI testing as well as data flow. So also we use NUnit for test framework, and also for the UI test, we are using the Playwright for the UI test library. You might heard of Selenium or Puppeteer, and this is the descendant of the Puppeteer. So we can use that. And Playwright supports multiple languages, while the Puppeteer only supports Node.js. So yeah, we are using Playwright for now. And as this time we also use container builder, right? So, but with container builder, we also need to provide some network binding as well, so that that actually the mimics Docker Compose, right? So each container needs to understand where I need to call the other container. I need to call the other container, something like that. So we also need to have the network binding capability in here, and also for the during the test process, we also need to install the Playwright. And in the if we want to get the web browser element, the HTML element, then we use page.locator method to pick up the right the HTML element. So this is the these two steps we are going to right now. So we have the 252, right? So I have 8 minutes. Why? Yeah. A little bit more.
It's 5 past the hour.
Yeah. So my session finishes 5 past 3. So we have a little 15. Not
13 minutes. We're going to be
yes. Yes. Yeah. So let's go back to the second step. So once you finish the step, and we are going to use the testing API, the API test stuff. So follow this step, and yeah. So we are copying all the project from the previous steps, right? And so yeah. So if you want to keep your existing the practice, then you can still use that. Or if you want to start fresh, then copy this same project from the step 1. So we have, yeah, so we have product API and writing the test code here. So we have something like, this is the test code something. So in here, so we use test fixture as a container. And as I mentioned before, this and the one-time setup start only runs only once, right? And within here, we build containers, right? So we use container builder with image of this the container image, and we use inside the container we use port 8080, but container host should be randomly allocated. So we use the true, and the container should be should be available after a few the seconds, something like that. And yeah, this teardown means everything the removes. And here the setup and teardown is this is run every time test start, before test starts, and teardown runs every time after the test
This is
finishes.
a performance thing. but the runtimes are too slow.
Yeah, that's right. And also, it's kind of a singleton concept. The singleton concept.
Yes.
Yeah. So, and these are all the tests. So we have like to send an HTTP request to the container and get the response, something like this. So these are all the tests for the API testing. And similarly, we use the weather API as well. And finally, yeah, so this is the container automatic build. So before that, we have to build the container image by ourselves. But if we put this automation, then we, while we are starting the test, it automatically builds container image for us. So yeah, this is the one. Now, if we finish that and we move to the next, the end-to-end testing from with front-end and back-end as well. So we use Blazor for the front-end application. So yeah, the same thing, and everything is that similarly we use that the similar approach, and also we automate installing Playwright. And once it's installed, and the second time it doesn't install anyway, so we use the Playwright installation automation here, and also we use the web application test code as well. So something like the same thing, one-time setup, and same thing happening. But this time, before building container, then we use to build network first. And this network need to be added into each container so that web application understand where product API is, where the weather API is. So this is something in here, something like this. And also we need to give each container with this alias as well, right? So yeah, this is the one. So so this has all the instruction, all the explanation of what the code is about. So read through and follow the instruction. And once you finish it, then you will be able to test end-to-end testing from front end to the back end. So yeah, that's it. So the follow through, then I don't think we have enough time to use .NET Aspire for container orchestration. So, but I will leave that to you to practice by yourself after this workshop session. So we have 8 minutes. Yeah, I think time is running out. So I will give some brief idea of what we are going to do next in the next step. So we are going to use .NET Aspire. And as I said before, .NET Aspire is the container orchestration tools, container orchestration framework. Even if it's written in .NET, and it can orchestrate everything, every container. So this in the step four, we are practicing how to orchestrate the older containers in .NET Aspire, and also as you might be noticed that so far we used a SQLite local database, but this time in this stage we are replacing this local database, SQLite database, with PostgreSQL container. So we are going to practice this kind as well. So even if it's not written in the code, but we are still using the containers as a container orchestration, and we are going to test it. So also, .NET Aspire allows the container orchestration, meaning it automatically do the service discovery. And also it provides dashboard. So how we can trace all the data is coming from the front end and back end using OpenTelemetry protocol. So it will be very useful. And as I mentioned, we are going to replace SQLite database into the PostgreSQL. And finally, we are using the test containers using .NET Aspire. This doesn't use test containers because then Aspire all uses take care of all the containers. So yeah, so even if we don't use containers, but it like mimics, we are actually using containers. So as I said, we are going to use NUnit for test framework and also Playwright for unit test and the UI test library. So yeah, so time's up. So if you still want to know more about test containers, visit this testcontainers.org and please take this picture. And also if you are curious about learning more about .NET Aspire, and go into the arca.ms/.NET Aspire. And finally, NUnit and Playwright. So this is something we are going to cover. We covered this workshop, all right? Oops. Do you need more time to take this picture? Yep. All right. Thanks for joining. Thank you.
Goals to go, well, we'll do this. Could we start quickly with things that work so well and nothing went wrong? Anyone, any questions on the book while we have this in the room?
Do you have any questions? There we go.
So my question is, actually, I played around with on the test container. I'm not sure if you have any experience on the using test container on the like making it more on the automation side, for example, CI/CD, possible to do something like that.
So your question is about how to use test containers in a CI/CD pipeline. Is that correct? Yeah, because it's just a framework. So it's just a library. So if you prefer writing your application in Java or Node.js, whatever, and yeah, you use you just import this test container, and within your test application or test project, and you can simply use it. And it's not different from your local machine or test the CI/CD pipeline. For example, if you use GitHub Actions, then yeah, run it and import. If for example, if you use a Node.js application, then just simply the npm install. That's it, and run it. Thank you.
Thank you very much.
Thank you.
Notifications from my friend here.
Yeah, absolutely. That's okay. Sure. Start. Good afternoon, guys. Good afternoon, everyone, guys and girls. Okay. Oh, we'll wait for some time. Okay.
Aha. Okay. Next up, we have Lavendra.
Right, that's right.
From FOSSASIA, who will talk to us about tools, techniques, and practices for reducing container use size.
That's right.
This is speculative.
Yes. Yes. Thank you. Thank you. So good afternoon, everyone. So I'm going to be talking about how you can slim your containers and why it is so important for everyone to reduce your container image sizes. So how many of you have worked with containers here? I'm sure you're attending this and you worked with containers, written Docker files, and done all of that. So we're going to delve into multiple aspects of containers deep down, and then look at how we can go ahead and reduce container image sizes. Anyone wants to tell me? So this session will be highly interactive. I'd love to get good responses from the audiences. It's my style, and I think the audience already know all the answers, and I think it's a way to just get those answers out. So, how many of you, anyone wants to share why you would like to reduce your container image sizes? Yeah.
I teach a class where 1,000 students will be submitting the papers for my evaluation.
Okay.
I have to download
Okay. Okay. That's a good problem to have. Good. So cool. So the talk will be outlined in probably like 7-8 steps. So first we'll go into a concept called overlay file systems. Okay, this is an important concept that I think everyone should understand if you really want to understand how containers work inside out, right? So next we're going to look at how a Docker image or a container image is layered. Next we'll look at how we can optimize for build times. Next we'll then look at an open source tool called Dive. Okay, that'll help you look at your images and analyze them. We look at a very important concept called multi-stage builds, and this is a very good technique that will help you reduce your Docker image sizes by up to 80%. Then we look at a concept called line buddies. We look at another important tool called Docker Squash that helps you, reduce your Docker image sizes by, looking at inspecting the image and trying to see if you can optimize further and, add some lines together in your Docker file and, optimize it better. We look at another concept called lazy pulling. Yeah? Cool. So this is going to be a very simple concept. Overlay file systems essentially comprises of 3 layers: a lower layer, an upper layer, and an overlay layer. Okay. So what is a layer here? A layer here refers to a directory or a set of directories. Very simple. So let's say in my lower layer, I have these 2 files called ll1.txt and ll2.txt. In my upper layer, I have 2 files, ul1.txt, ul2.txt, and an overlay layer, right? So what the overlay file system helps you do is it helps you give a union of all the files from the lower and the upper layer. Okay, so this is going to be the final look of how your overlay file system will be, which is a union of all the files. That's ll1.txt, ll2.txt, ul1.txt, ul2.txt. Everyone with me? Everyone with me? This is okay? Okay. One important concept that we have to look at when we're looking at overlay file systems is that any change that you make for a file that is in the lower layer will not be updated in the lower layer itself. So let's say I'm here. So let's say I'm here and I change ll1.txt in the overlay layer. Then the change is not happening actually in the lower layer, but a copy of that is created in the upper layer. So we'll look at this quick demo, which will help you understand how this works. Okay. So let's say I have this folder. I have a lower directory here, an upper directory. The lower directory has 3 files: dup.txt, ll1.txt, ll2.txt, dup.txt, ul1.txt, ul2.txt. Okay? Okay. Now what we're going to do is create an overlay mount file system. Okay? So these are the contents of the files. We're going to create 2 more folders called the merge directory and the work directory. The merge directory is where your overlay file system is, and the work directory is a temporary work directory. And this is exactly how a mount, an overlay file system is created. That's using the sudo mount -t overlay type of file system, where you pass in the parameters as upper directory, work directory, and the final overlay layer is the merge directory. Okay, everyone with me? So we see that the overlay mount is now created. Okay. So can you see on the left side that the merge directory has the union of all the files, right? And the file name dup.txt, has it come from the upper layer or the lower layer? Because we saw the same name in both the layers. Can you tell me from where it is taking it from? Any guesses? Yeah. Anyone else? Yeah. So if you see, there is a dup.txt file in the lower directory as well as the upper directory, but in the merge directory you see only one dup.txt. Can you tell me where it is taking it from? Sorry? Yeah, so absolutely right, it's the upper directory, and we can see how that happens. So you see it's the duplicate in the upper layer. Okay, so when you have conflicting when you have the same file names in both the layers, it always chooses it from the upper layer. So this is a rule of thumb that the way it is architected, right? Okay, let's say now I come into my ll1.txt, which was created in the merge directory, and I add a new line. So now we see that a copy of this file is being created in the upper layer. The lower layer itself is not being modified. Can anyone tell me why that's happening? So that's the way that the overlay file system is being architected. We want to ensure that the lower layer is always read only. You can't write to it. Okay. So this is a rule of thumb that the lower layer is always read only. So if you do any modification in the merge directory or the overlay layer, a copy of that is created in the upper layer, and it always, as we saw, when the file names are the same in both the layers, it always takes it from the upper layer. Has everyone got this? I think this is crucial for us to understand how to slim container images in the going on, and that's why we are covering this right now. Okay, cool. So another question. So what happens if I delete a file? Before I show it in the demo, can you guys guess what happens if I delete a file from the lower layer? From the lower layer, yes. Yeah, absolutely. Yeah. So what happens is, let's say it's a whiteout character device file that's created in the upper layer, which signifies that it's a deleted file. So let's see that in action. Yes. So this is where we're going to delete. So here I'm going to remove this file called ll2.txt. Okay. And now what's going to happen is, so do you see in the upper directory that you get this kind of a file? This is nothing but a whiteout character device file that's noted differently. I mean, that has a different notation, and this signifies that it's a deleted file. But mind you, ll2.txt is still there in the lower layer. Okay, right? So just think about this, keep this in your minds, that even if you delete a file from the overlay layer, it is still there in the lower layer, but in the upper layer there is a character device file with the same name created, which is basically empty. Okay, cool. So that's overlay file systems. How do we build a container image? So let's say that this is your Docker file. What is typically happening is every line in your Docker file is creating an intermediate Docker image, and then the final Docker image is basically a union of all the images that have happened till then. Okay, so what I mean to say is, let's say you have 10 Docker files, 10 lines in your Docker file. Starting from your first line, which is a base image that you kind of pull, that is one Docker image. The next line adds another Docker image, creates another intermediate Docker image. The next one creates another one. So this keeps happening, and you finally get the final Docker image. Yes, except yeah. So for example, in this Docker file, you see the first one that's creating the base image. The next line called run apk, that is adding a new image called image1, and every other line is creating a new image. And what do we mean by an image? An image is nothing but an overlay file system. Each Docker intermediate image or each Docker image is nothing but an overlay file system which has 3 directories, a lower directory, an upper directory, and a merge directory. Okay, so that's how it's architected and that's how it's built. Cool.
So maybe I can optimize, like I don't run two command. I can run app, let's say Python and C++ into one command.
Yeah. Yeah. Now, so that line is going to be another image,
Yeah.
and the second one won't be there.
But instead of I have a two image, one or two, if I run two commands at the same time, then I have the one image. Is that right?
Sorry, I didn't get that.
I mean, that is have to optimize it. So I don't want to run two app command with two separate lines.
Yeah,
because then I have full image.
Right.
I can run both of them
In the one.
command.
Right.
Then only one image.
Yes, yes. So that's one way you can probably reduce the number of intermediate image layers, right? Yeah, that's right. If you run both of them in one, you get only one of them. You get lesser intermediate images. That's right. So what this means is, I'm going to just give you. So this is going to be a simple animation which will show you how the final Docker image is created. With reference to this Docker file, right? So first we are going to install the base image, which is the Alpine 3.6 image. That is sent to the upper layer, and the overlay layer is basically reflecting the upper layer itself, which is the base image. Next, what happens is the Alpine file system that was there in the upper layer in the previous Docker image goes and sits as a folder in the lower layer. Okay, and the next instruction, Dockerfile instruction, goes into the upper layer. In the subsequent Docker intermediate Docker image, what happens is the lower layer has the previous two Docker, whatever the actions were there, whatever were there, are added in the lower layer again. The same way this keeps happening, and in the final image you have all the previous upper layer directories and the final instructions upper layer which is there, and you get the final image. And this can easily be, so you guys can all see this easily by running a command called docker image inspect. So if you run docker image inspect, at the end you will see there are three, you will see the simple JSON where you're shown the merge directory, the upper directory, and the work directory for the base image. Coming to the next part, in the lower directory, it is same as the upper directory from the previous layer. So whatever you see here in the upper directory goes as a lower directory here. And in the next one, you have both the previous upper directories. And in the next one, you have all of them. So this is how a final Docker image is being created, where every step there is a new Docker, every step of the Docker file, a new intermediate image is created, and the final one basically has all the previous instructions and actions. Okay, everyone's okay with this? Okay, awesome. So next we have a fun quiz where you can vote live. You can scan this QR code, and you please tell me which is a better way to compose a Docker file. This is a simple Node.js app. Yeah, probably use Golang, but this is just for a demo that I'm showing it. Can anyone tell me what is the difference between the two Docker files? The install step is happening before the copy step, and here the install step is happening after the copy step. And you can scan the QR code and vote, like which is the best option, do you think? Or you can also say, anyone wants to try? Okay, so let's see the results. Okay, so we see that 8 folks think it's A, 4 folks think it's B, and one of them says both are same. Okay, anyone wants to say, whoever's voted, anyone wants to say why it's A or B? Okay.
Dependencies after installation. Then on the second thing, you're just copying the app.
Okay. So I think I just want to give a hint here. Think in terms of build time. Think in terms of subsequent build times. What is most frequently changing in your app? Your code base, right? Let's say the core server file or the source file, right? So when you run copy dot dot before the installation in the second case, then what is happening is your as your code changes, this thing is running again and again, correct? Whereas if this runs once, then this has to run again because you're losing the cache here, right? Whereas in the first step, your npm install, you're not installing often, you're just working on code changes, you're not installing often. So until run npm install, it's cached. So these layers are cached, right? What do you guys think? You guys agree? Yeah. So option A is a better way to write your Docker file than option B if you want to, ensure that your build times are faster subsequently. So, okay, this is your first learning. Okay. Your second quiz. This will be the last one where you'll have to vote. Right? So, yeah, you can also vote for A or B. Anyone wants to say something? Yeah, yeah, yeah. That's only what? How does that benefit? Cool. So let's see the results before we kind of give away the answer. So okay, it's some people feel 4 of them are saying, oh, okay, 5, okay, okay, okay. Anyone wants to say why it's A or B? Sorry. Okay. Anyone wants to say why it's B? Fewer layers. How is it? Okay, fewer layers, but will the Docker image size remain the same for both Docker files, even if it has fewer layers? Yes, right?
You're installing more via app. That will take up more space. I don't know if that is needed or not. I know I've never used npm, so I don't know that.
Okay, but yeah, both the Docker files have apt.
Yes, but the second one you're installing. Sorry, the first one you're installing Redis, and the second one is only SQL Lite. Sorry, I saw both again. The second one you're doing Android. First one is only SQL Lite.
Okay, so sorry, I have to present. It's B, but the reason is slightly different. I mean, the reason is a little bit different, and you'll appreciate why it's B much more once I give the reason.
Because
you have some metadata for package installation, and this metadata will be updated twice. A.
Okay, let's see. Okay.
So it should be bigger, but not much.
This answer is actually not related to image size. There is a much more important reason why you would choose B, which I want to kind of explain to you. Maybe, yeah, maybe there is something with image size which is probably incremental, but let's say a new package is to be installed in the cache layer corresponding to apt-get update. Then what's happening is till apt-get update, your packet, the lines are already cached, right? So let's say I wanted to install Redis, then which package cache, I'm using old package cache, because sudo apt-get update will never run when I keep adding SQLite 3, Redis and more packages in the run apt-get install, SQLite 3, Redis, all of that. Because the first two lines are already cached. Did you guys get what I'm trying to say? So since the Docker file is not changing, you're only changing the third line by adding Redis and few other packages that you want to install over a week or 2 weeks. The first two lines are already cached. When the first two lines are already cached, your apt-get update will not run again when you want to install new packages. And when that doesn't happen, your package cache, which is the repositories from where you're installing from, are old. Okay, so that means when you're doing installations, you're always installing older versions in the first yeah, please.
So what we have run get update. You want to just run on every Docker image view?
Sorry?
Update update. You want to be run on every Docker image view?
Yeah, we want it to be run. I'll tell you why.
And if you run it, in A, it's also will be run and update package.
No, in A it won't, because in your Docker file, the two lines are always the same, which means when you keep doing Docker build again and again, the first two layers are already cached, so it will not run again.
But say run npm install, also never change. Does it mean that you never change npm install? Don't change anything.
No, but when you change an app, some files have changed, your package JSON has changed. That means run npm install will run again. So if you see, if your file system changes, your package JSON changes, then npm install will run again. Basically, if there's a change here, let's say the app directory has changed, then this will run again.
So that instruction doesn't create a unique ID. Each line a unique ID. So when you run get app and you see nothing changed,
Yes.
why will I do anything?
It will not do anything. So it will always pick it up from the old cache repos.
Suppose you're not running Docker and you just want to say on your command line, I want to install Redis. How you go usually on any Linux?
You will just run
get update, right? Because you want to make sure. That's why you also want to issue like this.
So always run. So let's say, so when you want to install new packages through a Docker file, always run apt-get update along with it so that you have the latest packages. This is the main important lesson that I'm trying to share. When you run these two lines separately, there may be aspects where you're already caching the lines before, and hence you're not getting the latest packages. So always run these two lines together so that you always have latest packages. Okay? Everyone agree with me? I think it's for you to try out. Yeah.
So suppose you have the file and you have the app getting SQLite 3 and you modify that file to have SQLite 3 already.
Yes.
If you run the Docker file, now you should not run the app update.
Exactly.
That is the advantage.
Exactly. That's why you got to add apt-get update and apt-get install together. Exactly. I think you should try this. I'll share my presentation and you can try it out as well.
You can see the transaction ID, so that how it changes when you
Do this, yeah.
Because this is for you. This is like the upper language, like C#, but in the end, it's going to be or like an intermediate language or a compiled language. See what is like that. This is a DX feature.
Yes. So we'll move on to the next one. So I promise you there's no more quizzes. Okay. Yeah. So I think one thing that we want to remember when we create Docker files is we have to order from the least to most frequently changing content. Okay, for the first scenario, we saw how cache actually helped us, right? And the second scenario, we saw how cache actually did not help us, because a disadvantage of having cache is sometimes you're installing older versions and you're not always up to date. So we see both scenarios, and having line buddies where you have, this is the concept of line buddies where you have apt-get update as well as apt-get install in the same line, right? Okay, so let's look at this scenario. So this is a simple Node.js app. This results in a 1.3 GB sized Docker image. Okay, and this is the corresponding package JSON of that. I don't know if everyone is familiar with Node.js, but this is the corresponding package JSON file here. Can anyone tell me if I can make this smaller by just looking at these two things? Yeah, absolutely. So dev dependencies are something that you may not require when you're in runtime or when you're executing this whole thing. So what you can do is you can change your Docker file to do npm install prod, and then you can which will disregard your dev dependencies and install. Okay. So we do not need this during runtime, right? So this is one way you can reduce. I'd like to introduce you to a tool called Docker Dive. Okay, this is a very nice tool that helps you inspect your Docker image and go layer by layer and see how your file system has changed every layer. That means you can inspect by adding a new Docker file, have you added some stray files by mistake or that are not needed, and you can have a look at the file system every line of the Docker file, right? So I'll just show you a quick demo of this. So the way I invoke it is dive node app simple. Node app simple is a Docker image name. It just takes some time to kind of load the whole thing. Yes. So okay. So as you see here, this first line that you see is basically the line that corresponds to pulling your base image. Pulling your base image goes until here. The first 4 or 5 layers together is pulling your base image, and you see how as I go through each line how the file system on the right has changed. Yeah.
I used it before.
Okay.
What I what was challenged
Yeah.
is that most there is very long list of files.
Yes.
Changes happens beyond the screen.
Yeah. So what you do is you minimize everything, and then you go folder by folder and then see which is of interest to you and expand each file. So if you go here, you can minimize everything. Let's say etc has changed, then you click spacebar, you get file folder wise changes. Okay. Yeah, I mean that's the tool that we have, but it's a nice tool. And let's say we have the next line. This is where you're saying that slash app workday slash app, and you see that the app folder has changed here. And here you see how things are being installed and how the etc and var and the user directories are changed, right? So this gives you a visual representation of how every time there is something that's changing, how you can keep a track of it. Cool. So let's look at this concept called multi-stage builds. Okay, multi-stage builds makes use of the concept that uh, you can probably split your Docker file or compartment your Docker file into two by having a build stage and a runtime stage. And it's not necessary that you need everything in the build stage to be there in the runtime stage, right? So we exploit this, this aspect, and then we try to reduce Docker images. So consider this Docker file. Here what we have is a Node 22, a Node.js image, and we're doing some installations there where we have omitted the dev dependencies, as you see there, omit equals dev, and then you copy the whole source code. In the second part, what we do is we pull a slim version of the node image. Okay, and what we do is we now run the server file from this part. So what you see is a huge reduction in the image size. So you can see that the size is reduced from 1.2 GB to less than 300 MB. I just have a question for you guys, maybe something that you can think about, but what is causing the change here? Why is it reducing to 300 MB? Yeah, absolutely, absolutely. So your Node Slim is a small image compared to Node 22, which is the base image, which is used for building. And Node Slim does not have things, packages like Canvas and things like that, where you don't need those packages, or you don't need some of the features of the actual node image for during runtime. And that's the basic difference. The Node 22 image is huge, whereas Node Slim is quite small. So we're using this, and then that's how we are getting a small image of less than 300 MB. Can we do better? So I'd like to share about something called distroless images. Okay, this is something that Google came up with. So what Google has done is they've released distroless images for a lot of important languages and packages, OSs as well, where you can install a Node.js Debian 12 distroless image, and your app size even reduces further to 150 MB. Can you guys believe it? So why is this happening? This is happening because this distroless image that you see, that is Node.js 20-Debian 12, does not have a shell, does not have many things that are there in a typical OS. So a lot of things that are there in typical OS are not there in this distroless image, and that's why its size goes down even further. And again, it exploits the fact that there are a lot of things that you use during build time that are not necessarily required during runtime. So this is the main aspect of multi-stage builds and distroless images. Right, so your distroless image doesn't have a package manager, doesn't have a shell, and so many other things. Yeah.
You can go into user and switch to image without operation system.
Sorry.
You can switch to image without operation system. Then you will have only binary of your application.
Yes, so that's a very good point, and there is a community working towards something called unikernels. Okay, so you can check out this thing called unikernels, where a lot of things are there where you actually don't need,
So you just deploy your application, help them use
Yeah.
the image.
Yeah.
And then we don't have any aberrations inside the image.
Yeah.
Because it looks normal and your application.
Right. So I agree that's possible, but there is a toll on the developer, ease of using these images, someone else taking these things and then building on top of it without having an OS. And I think that's also probably the concept that unikernels is leveraging, where you have a separate unikernel for each language, let's say a Python unikernel, a Node unikernel, Go unikernel, things like that. Right. So I think that's where that's what is being explored, but it kind of takes a toll on the developer ease and developer usability of this whole thing. Okay, going ahead, I'd like to show you this one. I think this is probably one scenario which will help you understand how we can again reduce Docker image sizes. You see the first part, I've implemented a multi-stage Docker file. The first part, I'm installing a few things. In the second part, I've again switched to a Node 22 Slim image. And what I'm adding here is I'm installing AWS CLI. Okay, that is using these two commands. I'm installing AWS CLI. Can anyone tell me by just looking at this how I can reduce further? Yeah. Sorry. Yes. Yeah, absolutely. So, and then how do you move the, and then you should not forget to move the AWS stuff into the runtime stage. So that's excellent. That's one point. Can I do this? Sorry. Yeah. Can I do this? So the earlier one was this. This was installing this whole thing, this AWS thing. And then what I'm going to do next is I'm just going to delete this whole zip and this thing. Will this work? Why? Sorry?
If you would make another image based on that image,
Uh-huh.
then it would work. You delete it in the same view.
Yeah.
Underline layers
Yeah, yeah, absolutely, absolutely. I think he got it right. So what he's saying is, as we saw in overlay file systems, if you delete something, if you try to delete something, then it's not deleting from the lower layer, but only deleting, it's creating a new charactered whiteout file in the upper layer, but it's not deleting it from the lower layer, right? So that's why your image size is still the same. So I think you should, when you're writing your Docker files, you got to try this one thing where you just do a delete of a directory in the next line, and then you'll see that your Docker image size still is the same. Image size is still 777 MB. Even after you say run rm-rf, this whole thing. This is because you're not deleting it from the lower layers. The lower layers still has this whole installation file. You're only creating a whiteout file in the upper layer, which shows in the overlay layer that there is nothing there. Okay, everyone got it? Awesome, awesome. Absolutely, absolutely. So that's where I'm coming next. So what I'm going to do now is, I think he's guessing what my slides have, and he's going to the next slide and perfectly telling what's going to happen next. So what I'm going to do now is going to install and then remove everything in one line. What is going to happen here now? It's going to install and remove everything in one line, right? So now even in your lower layer, it's not there. Okay, so what this happens, so just, I think you should focus on the aspect that when you're installing something, also try to remove whatever are the traces of those installations in the same line so that you reduce your Docker images further, image sizes further. So now from 777 MB to 506 MB, you're able to reduce the size. Okay, everyone with me? Cool. I'd now like to talk about a very nice tool called Docker Squash. Docker Squash helps squash multiple layers. So there's a way where you can, let's say your Docker file is composed as line 1, line 2, line 3, line 4, line 5. Docker Squash helps you combine all your Docker file lines into one line. It will be Docker line 1 and Docker line 2 and Docker line 3 and Docker line 4. So this is simply what Docker Squash does. And it definitely, so let's say I had an image from this where I had a rm-rf in separate lines. If I Docker squash this, then it would put all these lines in one line, and I would just have, I would not have a big image size. Okay, so that's how Docker Squash will help me in squash. Yeah. Sorry?
Does it incentivize bad Docker files or bad practices in Docker?
So I'll tell you how they've tried to kind of avoid it as well, by giving an option to choose the layers that you want to squash. So you need not necessarily squash all layers. You can choose how many lines of a Docker file you want to squash. You can probably choose to squash, let's say, the installations to the, to probably from top down, how many ever lines you want, you can choose. Or if you don't want to squash those, because you may not have that much use of it in the top layers, you can only squash at the bottom layers, right? So I think by adding a feature of having to choose how many files you can squash in using Docker Squash, I think it kind of gives that flexibility where you're also taking advantage of Docker files. And Docker squashing is not always useful, because you're then also not making use of the caching aspects of how Docker file works. If you squash everything, then every time your image is run, it is being built again and again when you squash everything, when there's a change. So hence, you have an option to choose how many lines you want to squash as well. So this is a typical example of when to use Docker Squash, right? It helps you clean up unnecessary temporary files from previous layers and reduces your final image size. And it also helps you do partial squashing. That is, you can choose how many layers you want to squash as well. Okay. Okay. But there are a few limitations of squashing. When you want to squash these layers, the resulting images can't take advantage of layer sharing or caching that I was talking about. And it also will have a negative impact on performance, because a single layer will take longer to extract, and you can't parallelize downloading a single layer. Okay. Okay. One important question: what can I do once I'm unable to reduce my image size further? Why are we reducing our Docker image sizes? Apart from the reason that the gentleman gave, yeah.
The less you have on your Docker image, the less hard to print you have.
Absolutely. So two great points. I'd like to add another point, which is basically faster deployment timelines, faster deployment or faster runtime, faster. Basically, everything becomes faster, right? If you have smaller images. So can I do something better to make my whole deployment faster? So the traditional format of a container image is a gzip of multiple tar files. Okay. When I want to run a Docker image, I need to download the whole Docker image into my file system and run it. That means I need to download it, extract it, and then it will choose what file it wants to run, and then the whole Docker container will start running. This is how the traditional container image is layered and how it is run. And pulling a Docker image accounts for 76% of a container startup time for a cold node. there are scenarios where it is very expensive to cache a Docker image as well because of its huge size, and in that scenario you need to work with core nodes, and in those scenarios 76% of the startup time is caused by the pull operation, which is downloading the container image itself. So I'd like to introduce another concept called lazy pulling of container images, where the whole community, containers community, has embraced this whole thing where Google first released the container registry file system CRFS, and uh, released a new kind of a Docker image format called stargz. Okay, so what a stargz format image does is basically it takes the tar file in your whole thing and zips that individually. So there's a gzip of each tar file of your container in your container image, and this still retains the standards of the gzip itself. And one crucial thing is, at the end of this whole stargz image, there is a JSON file which shows the file as well as the offset and the file size. So if you need a particular file from that container image, you can refer this JSON and then grab that file using the index. So basically you don't need the full image when you want to start a container. You can lazily pull an image. That means any tool, any runtime like containerd can choose which file it wants to run based on the Docker file and based on other instructions, and choose and retrieve only those files from the container registry and run them. And this significantly, what happens is, this significantly improves your pull time as well as your create and run times. So here is a very good benchmarking study that was done, where legacy is basically what the traditional container image pull is. eStargz no optimization is basically the plain stargz format, and eStargz is a more advanced stargz file format where there are options to prefetch, let's say, the OS files, and prefetching some important maybe packages which are related to Python or languages themselves, right? So they have an option of prefetching in eStargz, which makes it much easier to have this whole pull operation and the run operation with reduced times, right? So I mean, it'd be great if you guys check out this whole concept, check out this package called stargz snapshotter, and it'll help you reduce your deployment times as well. So this whole thing that I just showcased can be tried out through a platform that I've been building called QuestoDev. So you can try out each of the concepts that I just kind of talked about, and yeah, you can basically appreciate it for yourselves by trying out each of this. Yeah, so that's me. You can connect with me, and I'd love to get some feedback as well if you guys thought this was useful, or if you have any other questions you'd like to chat about something. Yeah, so that's about it from my side. Thank you guys for attending and being so interactive, and thank you.
We've got a little time for some questions, but before we start that, is anybody in the room?
So which person?
Is anybody in hand in the room?
Yeah, you know that.
Who's that now? Right. Do you have any questions?
Thank you. Sorry. Ask for questions.
should be already. Oh, not that.
Which one?
I should.
Sorry.
Do you know how to get a slide?
You need a lot of like puzzle.
Do you know how to get a slide?
Yeah.
I have been looking for a lunch.
I use it. That's
Already have
microphone.
Yeah.
Yeah, we've got like this.
Did it work? Sorry.
Okay.
And thanks for the documents.
Okay.
Yes.
With you. Right. 3, 2, 1, go. 3, 2, 1, go. All right. All the magic plumbing is working. Fantastic. Yeah. Or if you, oh, yeah, we'll just, that double technique.
Face our service. We have this smart city and another today. During second year in COVID, so 2022, we did online, but yeah, 22. So, hey, online, we're not constrained by the time, so we can do one track.
Right, I remember the
For 9 days.
one long track.
For 9 days. It's like, that was a really stupid idea.
I remember I couldn't go in as a
From like one Saturday to the following Sunday. Unique experience.
Yes.
3 days, yeah, it's a little more practical. Okay, so we have one remaining session before we get to head out and socialize. So with Han is part of the Ubuntu Local Community Council.
Yes.
And will be talking to us about building Ubuntu-based container images under this distro approach using Minecraft. Take it away.
Hello. Okay, boss. Okay. So welcome to my workshop, and my name is Youngwei. Yes, introduce. So maybe I can have a look at this page. So I'm also involved with the Ubuntu community, mostly for the organizing some events. Like I'm the local council and also Korean local community, and I'm also organizing Asia and South Korea. And I'm also one of the some founders involved with the founding the organization called FOSSASIA. And for the work, I work as a software engineer in the Anand province. So that was my introductions. So we'll be doing a workshop today. We'll be using a tool called Rockcraft to build container image. So to give you some quick introduction for those, so there's something called Rock. Rock is basically a container image. It's like just like the container image you know that you build with the Docker file. It's also a OCI container image, but between the Ubuntu edges based. And so why using Ubuntu as base? Because the creator of the Rocket, they want to leverage some packages in Ubuntu, which is usually if there are any security issues, which is fixed quite quickly. And inside the rocks, which is like a container which uses Pebble as a service major. So if we usually run a container, there's a program that you want to inside, and usually that program is the first process of your container. But in the rock instead, it is when you run the rock with like a Docker, it first executes the Pebble, which manages the other underlying some of your programs. Then your program is run by the Pebble. So Pebble manages the other underlying processes in your container. And like unlike the Docker file, it uses some YAML format for defining your container fields. And and RoughApp, you can also it also provides some seamless chiseling experiences. So chisel is basically a tool for building a lightweight container, of course, based on the Ubuntu. So I'm also giving more explanation for that. And We also have a rock thread, of course, it's a tool for building rock. And yeah, you can define your content in declarative way using the YAML format. It actually uses the quite similar format from the Snapcraft. So Snapcraft is also a tool for building a package for Ubuntu. So if you use Ubuntu, there's a Snap packages, right? So you use the Snapcraft for building snaps, and you also use rock threads for building rocks. And they actually use the PyScan format. So if you, I think most of you might have not tried out Snapcraft yet. So if some of you might have tried out Snapcraft already, you will be also easy to try out the rock thread for making container images. And there's a Chisel. So Chisel is a tool for building library container images. It's a good tool. And how it works is that if there is some data packages from the Ubuntu archive, like the name suggests, you can cut off the part you only need for your container. Like if you look at the data packages, there's the compiled binary and also some kind of license files, like configuration files. And this is actually some kind of license file for running your software inside container. But so if you remove that, you can actually downsize your container images. So we use Chisel to bring the only lead part from the different packages and use their slices to build images. So when you're using Chisel, there are actually already defined slice definitions in the GitHub. So we use that definitions to cut up only lead parts building containers. And yeah, this is example for the building using Chisels in container Docker file. So when using Chisels, we usually use the Chisel command line interface. You install it inside your Docker file, and then use these commands like Chisel cut commands. Then you declare the some release. So on which release you want to pull some packages and what kind of slices you want to use for building containers. So you use this kind of commands usually in Docker file to chisel out some packages. So for example, in this Docker file, so this command is actually pulling slices from some packages called libIC74. So if you look at some Chisel slicing definitions of this libIC74, there's slices called libs, which only contains libraries, and you can use these definitions to only bring the library files for containers. So you can use this way to add only the dependencies in the containers. So when you're using the Rockcraft, they also have their own life cycle for building images. The life cycle concepts are actually also quite similar or exactly the same as using the Snapcraft, or there are also tools called Jumpcraft. I haven't tried out Jumpcraft, but I've tried out Snapcraft, and the life cycles are very quite similar. So there's life cycles called pull, overlay, build, stage, and prime. So on the pull stage, you bring every source code that you need to build. And on the overlay, you want to, the overlay stage is actually something specific to the Rockcraft. So on the overlay, you use, if you want to manipulate some base images, then you use the overlay. Like if you might want to remove some unneeded files, like if you only want to use some only one text editor, you can remove other text editors from the edit stage, on the base image, and on the build stage and stage, just like the name suggests, on the build stage, you actually build your program on that stage, and on the stage, because on the step called stage, so you handle the outputs for the build files, so you can organize your build output for your containers. So, and then we have the final prime stage. So prime stage and prime steps and the stage steps are quite similar. We also do some organization of the prime steps, but the different thing is that the stage step, this is done by the each part. So when you work with the rockets, you can actually define the multiple parts. Like if you're going to build multiple objects. On the prime, this is the final stage that you can work with you can work with the output file from the every stage, every part. So this is the last part before putting this in the one place. So these are some life cycles for the working with the rockets. So there will be some quick explanation for the rockets. So we will be using a website. So if you go over to this link, I think you guys have a laptop with the network connection, right? So if you connect this link, pillarporta.com /rockcrafts-workshop, and you can actually go to the workshop link. Okay, let's head over to this link. Yes, so you should be able to enter the Kiloporta website. So if you log in, you can actually get a Ubuntu shell that you can use for throughout the workshop. I think I need to log in. All right, so after logging in, you should be some pages like this. On the left, you should be able to see some instructions, and on the right, you get a boot shell. So yeah, now you get the shell. So here's what we will be doing throughout this workshop. So we'll be installing tools, but you don't need to actually install tools. This will be done automatically. Then we'll be creating an example project, which will be a API project. And then we're going to write a simple rockcraft.yaml, and we build a rock. Then we try to run it on Docker. And after that, we will also try to use the shift feature, which is integrated in the rockcraft. So let's start this course. So I think the tool should be being installed. So if you go to the down and if you check, okay, so it's still being installed. So it takes time. So while waiting for the tools installed on the background, I'll just show you how to install some tools in case you will be doing something manually. So if you look at the some instructions on the left, so we'll be basically installing FB, which is a tool for running the system containers, and the Rocklet, and Chisel. They are all SAM packages, so we'll be using SAM to install these. We try to install. Okay, this is the first thing. Okay.
It's like you've done this before.
Install. It's already done, I think. Okay, it's not installed. So, all right. So let's continue to the next steps. So we'll be creating a simple .NET API project. You just need to enter this command, like .NET View Web API. Yes. So this will be generating a simple project for you. You don't need to worry about watching C# code. You won't be looking at it. You just try to run and how it works. So once you're done, you enter the project directory. Let's just run cd.net web API like this. Then let's try to run these simple applications. So you use .NET run URLs HTTPS. No, it's sure just HTTP. 4 zeros with port 5000. Okay. So we can build then run our .NET apps like this. All right, so the application is now running. So to check if it's running, you can click this link here. So the application has some simple endpoints called weather forecast. It's just an API that gives you random data. It doesn't have any meaning. So we just check that. We're just using this to check if the application is running properly. So, so it seems like the application is running well. So we're not going to. Okay, nice. So, all right. So we have checked the application is running. Then let's stop it. You see Control C for that. Then let's now start with working with the reference. So. To start working with that, so we are now in our project directory, right? So if you look at the LS, yeah, so we see some files for the project, right? And then we create the generate the Rocket file here. We can use the Rocket init command to create a simple Rocket file. Right, it's done. So if you have a look at the top, you can see the editor tab, right? We can actually use this to edit our files. Okay, it takes time.
Do we have anyone open this editor? Is it still loading for you?
Yes.
Okay. Let's just edit into. I'm just going to use nano for this. Nano, and there's a rockcraft.yaml. Let's open this. Yes. So let's try to work with this file. So this is the how rockcraft.yaml works basically. So you have some metadata on the top, like a name, the base images that you want to use. You can only use Ubuntu, sorry. You cannot use other distributions. you can define what kind of Ubuntu version you want to use for the container. You define the version for your image and some descriptions and platforms. So really just keeping the name and base images for now. Let's just, why don't we update our summary and descriptions at least? So I just try to simply copy paste here. No, not this one. Okay. Yeah, yeah. Let's replace these descriptions here. Yeah. You can enter whatever you like here. Then descriptions, I just keep it for now. So on the next step, we'll be working with the part, which is actually used for building your container build. All right. So the part is actually something we use for how the container will be built. So first thing will be change this name of the part to the .NET Web API. So currently it's saying the part name is my part. So let's change it. Yeah. All right. Then we won't be using any plugin for now. Then we add some information for the source. So this is about where you will be pulling the sources for building the containers. Right. So we have added two properties here. So first type will be local. So we'll be using files in the local and the same directory. And now we add something like let's add some environment variables. So we'll be using build environment. So So on the build environment, let's just have a look at this one. So on the build environment, we'll be adding some path here. So we use this path configuration for when we are on the build stage. So we added a path. Then let's also add some build packages, which we'll be using as a build dependencies when on the build step. So on the build packages, we'll be adding a .NET SDK, which will be a tool for building your .NET application. Right. So then we'll be adding override build. So this is something we use to override scripts from the plugin, but we don't have any plugin, right? So we just if we just add this comment, so the only thing will be run this rock build will be just what we added here. So graphic tier default .NET So I've done a build comments right here. Yeah. So let's just copy paste these things. Okay. Good. All right. So we have 4 comments here. So GraphQL default is something you haven't seen before. So it's something like when you're some kind of yeah. So if you use the GraphQL default, it actually runs the command scripts that are already provided by the plugins. So if you want to run both on the overall build, you use this command. So running this default command will be also executing some commands from the plugins. If you actually want to execute some scripts provided by this plugin, maybe on the next step, you can actually move this command to the bottom, so that it will run after running your custom commands. So we have added some configuration that needed for the build. Then now we're adding some stage packages. So stage packages is something actually needed for the runtime. So on this stage, we will need a dynamic runtime so that we can actually run our application. So on here, we'll be adding the ASP.NET Core runtime package. Right. So we have so far defined some metadata on the top, and we have added some configurations for our simple container, which uses the dynamic SDK package for building, and use these script for building our application. Then we use these packages ASP.NET Core to be included in our container, so that we can run our applications. So, how are you going? Are you following well? Okay. Now let's head over to the next step here. So we're now going to define how the container will be actually run. So here we actually use the service property. So this is something we actually use for the running the Pebble. So you can think it's a configuration for the Pebble. So on the top, we add on the between the platform and parts, we'll be adding a services like this. Then we define a service here. Okay. Then let's add something like this. So this is the command that will be actually run by the Pebble. So just like the description before, when we run the route after the build, so what is running inside is first we run the Pebble inside, then the Pebble launches your application. So this is command actually used by Pebble to launch your application. So let's add here. So we add 3 properties here. So the override is something used to replace the existing some definition. So there could be actually multiple service definitions in your graph. So if you want to override the existing one, you can use the replace, which is usually used. And startup is something you use to, if you're going to run the command at the below, will be automatically when starting off the container. So I think we want to automatically run this command when you're running the container, right? So we'll be using enable for this. And the command is the command you actually want to run. So I have added a done command here. So the done command with the some assembly file here that we actually want to run here. And we are also adding some environment variable for our container. So we'll be adding this one. Let me just copy paste also. Yes. So we'll be adding a ASP.NET Core URLs environment variable in our container so that we can make sure the application, the host name the application use will be this one, the 0008080 port. So we can make sure the application can communicate with the outside. Now let's continue to the next step. So we have wrote our first Docker file. So if you still haven't follow up, you can actually just copy paste these things. This is the complete one from our first step. And then if you have done with writing the Docker.yaml, let's save it first. And then we run Docker pack command to build our work. We build our work. I'll be using the V option so that I can see what's happening inside during the build. So let's build it. Okay, so now it's launching a Ubuntu 24.04 LXD container, and then trying to pull something. So it takes some quite many times to build, usually.
Jumping forward a step, what does the Rockcraft Scopio command do? Why are you specifying insecure policy?
So the Scopio command is actually not a Rockcraft command. It's like so we have installed a Rockcraft Snap, right? So the Snap package actually includes two programs. So one is Rockcraft, one is Scopio. It's actually a tool for like inspecting container images or importing things to Docker. So we use this command to import our rock to the Docker. Right. So yeah, I think the reason we have insecure policy here would be because we are loading images from the local image, so that we can load it into Docker. So yeah, so we can
meaning there's no certificate to verify at all.
Yeah, I think so.
No.
Yeah, so we import the OCR archive here, then load it into Docker table. Why is taking so long? Okay, so it's now creating new access point base. Right. By the way, how things are going with the building blocks for you? Maybe. Are you also working with the WordPress?
Sorry.
Have you also launched the building command?
Oh, yes.
How things are going for you? Does it also take long time for you?
Yes.
Okay.
That's good.
Right. So now we are on the build packages step. Okay. And yeah, so we have now pulled something and pulled our source. Now downloading some packages for staging steps. So it's pulling stage packages, which was the runtime package along with the other dependencies. And now building our application here. Right. And you can also see that Pebble is being installed inside, so that we can run our application through the Pebble. Yes. Then almost done. Right. Okay. So let's now check what kind of files here. All right. So now we got the .NET API.rock file. So we now import this into the Docker. So we use this one. So we use this rockcraft scope command. All right. So it looks like this here. And that would load your rock into your Docker, so that you can now use it as a Docker image, and you can use it to run the container. Then once you're done, let's check out if this was imported well. So we got the network API in the Docker now. Now let's try to run it. All right. Yes. So it now starts the Pebble inside the container. Then start our application. You can see. And let's check if this is actually working. So you can click the link here, the better focus, and then it should be show you this exactly the same thing as before. So if you see the same things as before, your rock is now working. Does it work? Does it work for you?
Still building.
Still building?
Yes.
Okay.
You've been very thorough.
Almost done.
Nice.
I think you guys will be still building, right?
I'm done.
You're done? All right. Then you can try to import it into Docker and try to run. Yeah. using the comments here. So I think the time is going up anyway. So let's try to continue to the next step for now. So the rock is still running. So I will start this for now. Then yeah, let's continue. On the next step, we will be now building a lightweight container using the feature that included in the Rockwell. So what we will be using in this step would be we'll be using a bare base, which is kind of scratch invoker. So you can basically think there are no files if you use the bare option for your base. And there will be also using the .NET plugin that is provided by the Rockwell. And we're also going to use chisel slices as our stage dependencies so that we can bring only needed file from our runtime. So let's open the Rockwell, that YAML, okay. Then we're changing our version to 0.2 here. And yes, after that, now we are using the bare base here. Yeah, we change this into bare then. But we still need to define which release we want to put packages. So we add another property here, which will be build base. So if you use the build base, you can define which Ubuntu release you want to put package for building your rock. Ubuntu 24.4. So we're using it on the build base now. So let's continue. So that makes we're now using the bare base images. Then let's continue in the next step. Oh, so I haven't set this yet. So we actually need to set this to go to the next step. So now we'll be using, we'll be updating our parts to use the .NET plugin. So to use the .NET plugin, you just simply need to change this new to the .NET. So using this plugin will be basically doing the job for building the .NET applications, something like installing some tool chains and restoring some .NET packages for you. Yeah, use the plugin here, and then we will be keeping the source type and the source property, and we're adding a new one, another new property here, which will be .NET build configurations. You can use that to define what kind of build configuration we'll be using for building the app. So this is something actually provided by the plugin. So we use these things provided by plugin to define what kind of config we're using. And then yes. So and then we will be now removing the override build because the .NET plugin already has the commands for building our application. So even if we remove it, it will now run the commands already included in the plugin. So let's try to, maybe we can comment out, maybe there will be, I think, faster here. right. Then on the next step, so we will now updating our stage packages. So for the stage packages, I've explained that we will using some chisel slices for this. So on the previous step, we also install a chisel command line, so we can use that to find some chisel information for the widget package. So we're using so chisel info command. To find out what kind of slices definitions for these packages. So running this command now fetches some some information from the repository. Yes, so these are the slices in these runtime packages. So we can see that we have copyright slices, and we also have library slices, like these slices. So what we will only need for building the container will be only these packages. So we don't actually need the copyright documents or something running our application. So we'll be using just it. So to use the these slices, using these slices is actually quite simple. So you just need to open the Rockcraft YAML again. Then you just need to put your name of your slices on the tail of the package name. So this is how you add these slices. Yes. So you declare what kind of slices you will be using, like this. Just simply add the underscore, then put the name of the slices. Let's save it. Right. Yes. So that makes our second Rockcraft definitions, which is now using which is now using the bare base and pulling some packages from the Ubuntu 24.04, and it's now using some .NET plugins for building your rock. We also use the chisel slices for our runtime, which is we are only pulling the list slices for the package. Then now let's try to build another rock for this. So we're using the same command line for this. So have you guys managed to build your first rock, by the way? Yeah, I did. Oh, I think you made it right already. This step. Yeah, the first one. You have already done the first one. And are you now working with the second one? No, not yet. Okay. Yeah, you can just watch my demonstration, and you can use the link to try this later. You can get the same environment to try out later. Yes. So now we got our second rock. So let's now also try this again to run it in our Docker. Now we're loading our second image. Yes, let's run it. So now let's check if it's running well. So we see no difference, so they should be fine because we haven't updated our code. So if you see the same thing, your work is working well.
But hopefully smaller.
Hmm?
But hopefully smaller.
Yeah, the small images now. So maybe we can now compare two files now. So yeah, so now let's use this command.
Oh.
Yeah, just comparing some pages. Yeah.
I have two that.
Yeah. So
Right.
there are difference here. The first one is like 100 megabyte, and second one we have removed the all unneeded files. So now we got the 72 megabyte here.
And so what's missing? Bash.
Yeah, no bash, no bash, and other like other files are also missing. So we only have some pebbles and runtimes and our application files. That's all. Yes. So there will be end of this workshop. I think I should be still working on it, right?
Yes.
Okay.
Where did you specify the G cell? Yeah. Where did you specify the how to say G cell is a tool to cut out the only file needed, right?
Yes.
Yeah. But I think I didn't catch up. But where did you specify what to cut off in the file?
Because Chisel it uses the predefined configuration to cut off the only needed file.
Yeah,
So,
yeah. In demonstration, where did you specify it for?
You mean when? Or
I mean the where did you apply the G-cell to your image in this demonstration?
It's in the YAML files.
yeah, in the YAML file.
file.
Yeah. Yeah, because I wanted to include only the runtime files in the container so that I can make it smaller. And if you look at the Chisel definitions that I have, maybe I can run it again. So
How extensive is Chisel's cover?
yeah,
How many things are there Chisel definitions for? Did you have to write the Chisel definition, or is the Chisel definition already exists?
there's a Chisel repository in the GitHub, so every configuration is already uploaded there. So we're basically using the definitions already uploaded there too.
So how much stuff does Chisel cover? The whole Ubuntu, or?
Not whole Ubuntu, so it basically covers most packages in the official Ubuntu archive, the main repository, and there are actually some packages doesn't have the Chisel definitions. So for that, you can try to contribute adding the definitions for those packages.
Okay, but basically it's a separate repository that covers the bulk of Ubuntu.
Yeah,
Wow.
there's a repository called Chisel releases in the GitHub. Yeah, you can have a look at that for the what kind of slices available. Yes, so I think we have only 5 minutes, right? So yeah, let me do some quick advertisement here. I'm organizing a Google Asia game, so it's happening in Kathmandu in Nepal this year in the August 30 to 31st. So we're looking for speakers now. So if you'll be interested, you can have a look. And we're also looking for sponsors, of course. And if you would like to learn more, you can visit our website, or we also have a matrix chat. You can join over there, then you can ask any questions. So yeah, so that will be all for my workshop. And if you would like to try this later, you can use the same link for that. And if you want to learn more, there's a link to the rockcraft documentations, pebble and chisel, of course. And there are also chat for the rocks here, which is in the matrix. You can feel free to ask any questions over there. And then maybe the maintainers will be giving some answers for you. Yeah, so here's the documentation.
All right. Any questions before we wrap? Going once, going twice. None. All right.
Yeah.
Thank you, Youngmin.
All right. Yeah. Thanks for the workshop. I think I need to log out my GitHub. Do we have anyone who would like to take these t-shirts? Swag! Take the swag! Anyone? Yes, thank you. I was ready. Perfect.
Thank you, sir.
You also want that?
Oh, yes. Thank you.
Yes. Have fun and let's catch up later.
Yeah.